I have described correlations and how to figure them. Now I'm going to talk to you about how to use correlation. There's some considerations though that you have to keep in mind when using correlations. Number one, you cannot figure the correlation between two variables that are not from the same subjects or people. This seems kind of intuitive, but it's worth bringing up. It would not be accurate to take the height figures for one group of boys and then the ages from a different group of boys. You have to get data from the same set of subjects. And number two, as I mentioned before, you cannot use nominal or ordinal data for calculating correlations. You need a continuous scale with variability. I cannot show a correlation, for example, between the amount of ice cream consumed by freshmen and seniors. The groups, freshmen and seniors, are exclusive, so the data points would simply line up vertically. Instead, I need a continuous scale for the years in college so that I can show the relationship. I want data on multiple first-year students, multiple second-year, third year, and even a half year in between to show whether or not there is a relationship. Number three, this goes along with the interval or ratio scale. You do not want all of your data points to be clumped together. In other words, you're not going to get an accurate correlation if you measure the height of 10 little boys all born in June of 2012. This goes to your sample and the discussions we had about that. You want a variety of birth dates to correlate with their height. You can see how important your sample is going to be. You don't want such a homogeneous sample that you don't see any variability. Remember too that the size of the group does not affect the correlation. Let me repeat that. The size of your sample does not affect the correlation. The size of your sample, or the number of subjects you have, affects the accuracy of your correlation. Number four, it's always best to at least make a scatter plot and see how the data points fall. If you notice that they form a curve, you need to be very cautious doing a correlation. Remember that you are using the distance from the mean for each variable. A curve cannot work that way. So you're going to find a very weak correlation. But it's obvious from looking at the scatter plot that there is a relationship and a pattern. You simply have to use a different kind of analysis to find the relationship when data is curved. Number five, and this is really important, correlation is an ordinal scale. It's not interval or ratio. When we compare correlations, they're always relative to each other, like winners in a race, first and second and third place. The R does not measure an interval value. R of 0.75 is not 3 times more correlation than an R of 0.25. All we can say is that 0.25 correlation is relatively quite a bit lower or smaller than 0.75 correlation. Now I'm going to talk to you about variance, and you'll need to go back and remember what we've already learned about variance. Let's imagine I'm interested in the reading test scores for fourth graders. This circle represents all of the ways that we could explain the variance in those students' scores. Think of all the things that could be related to how well a student does on a reading test, whether they're above or below the mean. Some of them we know of, there's good research, and there's multiple other factors, some of which we don't even know about. So all of these help to explain the variance in a student's scores. I'm going to narrow my interest down to the relationship between parent education and children's reading test scores. In other words, I'm trying to find the correlation between children's scores and the years of education from their parents. In my pretend example, I find that the correlation between reading scores and years of parent education is 0.62, which is a moderate correlation. In my group of fourth graders, the reading scores vary a great deal. I'm talking about the variance here. Remember that variance is a measure of the distance from the mean for all those scores. We took the square root of it to describe the standard deviation. By using the correlation between the two variables, I can show that some of the variance in the children's scores is explained by the parent education level. In other words, years of parent education can account for or explain a portion of the variance in the scores. So, I can separate the variance in all those scores in that pink circle into two variances, two different variances. I can portion it out. I have a variance in the scores that's related to parent education. And I have the variance in the scores from all the other factors. So this overlap represents the variance that's accounted for with parent education. The rest of the variance is accounted for by other factors. I can actually find the percentage of the variance that's explained or accounted for or related to parent education. All I do is square the correlation. The pink circle represents the area of all the variance in the scores. The whole circle is 100%. I now know that the portion of the overlap is 0.38 because I square the correlation coefficient, which is 0.62. And when I square that, I get 0.38. That means that 38% of the variance in those scores in the pink circle is related to parent education. It also means, so 38% of the variance, it also means that 62% of the variance in that pink circle is accounted for by all the other measures. I'm turning back to my bike helmet's poverty correlation from the previous lecture to give an example of how you report this explanation of the variance. Please remember that my example of reading scores and parent education was completely made up. To report the explanation, going back to the bike helmet idea, I would suggest for elementary school students, 77% of the variance, r squared equals 0.77, p less than 0.01, in helmet wearing rates was explained by the poverty rates as measured by percent of students receiving free and reduced lunch services. After all, note that my report fits with the original research question that I had. After all, it would be really absurd to say that 77% of the variance in poverty was explained by the rates of helmet wearing. You have to use a little bit of common sense here. We've covered a lot this week. Remember that a correlation is a measure of the relationship between two variables. If the correlation is positive, an increase in one variable is associated with an increase in the other. If the correlation is negative, an increase in one variable is associated with a decrease in the other. Correlations are ordinal. We commonly represent the correlation with Pearson's. And finally, the correlation can be squared for the coefficient of determination, and that gives us the portion of the variance in one variable that's associated with the other variable.